Hello and welcome back. In this lesson, we'll talk about IPTables options, flags or switches. These options specify the desired action to perform, and only one of them can be specified on the command line unless otherwise stated. Also note that all of these options are written in uppercase letters. Let's see what options are available. -A means append the rule to the end of the selected chain. Let's look at an example. I'll append a rule to the output chain that drops incoming traffic to port 25, so SMTP traffic. IPTables. It's not necessary to specify the table, it's by default the filter table. So I don't write -t filter. I could write if I want. -a, the name of the chain input, -ptcp, it's TCP traffic, -d port 25, the packets are going to port 25, -j drop. Before hitting the enter key, I want to test that port 25 is open. From another Linux machine, I'll scan that port, and I'm gonna use nmap. nmap -p the port 25 and the IP address of the Linux machine that I'm scanning. By the way, you could simply install nmap by writing apt-get install nmap. And we notice that port 25 is open. And I'm adding the IPTables rule. I'm scanning the port again. And the port is filtered. This IPTables rule has dropped the packets to port 25. Let's add another rule that blocks incoming traffic to port 80. IPTables -a input -p TCP -d port 80 -j drop. And I'm also installing a web server to test it right. It's very easy to install a web server on Ubuntu. I'm installing the Apache web server. From the other Linux operating system, I'm gonna scan port 80. The port is filtered, and if I list the firewall, I'll see a lot of matched and dropped packets. Each rule has dropped 2 packets. Another important option is -i. -i inserts one or more rules in the selected chain on a specific position or on top or position 1 if no position is given. Let's look at an example. I want to drop incoming traffic to port UDP 69, which is TFTP, Trivial File Transfer Protocol. Instead of -a, I'll use -i. The chain is input -p, the protocol is UDP, and the destination port is 69. -j drop. Now I'm listing the firewall. We see that the last rule has been added on top of the input chain. Now that rule is the first rule in the chain, and this is very important because rules are traversed in order. If I want to add a rule on a specific position, for example a rule on the second position, I can simply specify the position after the name of the chain. Like this. I'll insert this rule on position 3, on the third position. And the rule is on the third position. Let's suppose I've changed my mind and I want to accept all traffic to port 80. Remember that I've already added a rule that drops traffic to port 80. I'm running the same IPTables command, just that instead -a, I'll use -i. Okay, this is the rule. I'm using -i. And instead of drop, I'm using accept. Instead of appending the rule to the end of the chain, the rule will be added on top of the chain on first position. We see the rule on first position on input chain. Pause the video for 30 seconds and think about what will happen. Will the traffic to port 80 be dropped or accepted? Let's test it using the browser from another machine. I'm writing the IP address of Linux 1. And we see that the port is open. We could connect to port 80 and the page loaded successfully. When I've added the rule using -i, the rule became the first rule in the chain, and rules are traversed in order, top to bottom. When a packet is arriving to port 80, the first rule matches the packet and accepts it. Accept is a terminating target, and that means that the packet is accepted and no other rule will check the packet. So in fact here, the rule that drops incoming packets to port 80 will never be evaluated. That's why the packets were accepted, and this is an example of why the order of the rules is so important.